My name is Marcia Villalba. I work for Amazon Web Services as a developer advocate, so in the serverless team. Quite coincidence. I've been doing serverless since its early beginnings in 2016 when everything was coming together. Lambda, that was the first thing that we called serverless, was launched in 2014 at the end, and I started on the beginning of 2016. If you want to learn something about serverless and you want to get started or you want to learn some advanced concepts, I recommend you my YouTube channel where I have over 400 hands-on tutorials. And at the end, I will give you a resource page with a lot of information specific to this talk. And if you have any questions through your learning journey related to AWS and serverless, please reach out in social media. I'm always happy to reply in LinkedIn or in X. So this story comes from my personal story. So in 2016, I knew nothing about serverless. I was a developer and have some knowledge about the cloud. And we had to do a migration. And we ended up migrating to serverless, our existing application with a lot of traffic. And let's say that we didn't have a lot of experience doing migration. So we took a very wise approach of starting to build everything from scratch again. Very wise, very wise. We decided to build everything from scratch. We took 9, 10 months to build that. And then when the time came, when we were feeling ready, we changed the plug from one side to another. And you imagine what happened. Nothing good. And that was horrible. It was a horrible experience. Later on, when I tell this story, people are like, why you didn't do the strangler pattern? Because I didn't know. So now you know. When you do a migration, the strangler pattern is a good pattern to follow. The idea in the strangler pattern is that you grab an application and you start migrating bits by bits. So you can put it in production, you can learn, and then migrate a little bit of your application. We didn't learn in the process that much because we never put real use case in our application. So when we were 9 months in, we were like getting that first lessons. And it was rough. But a lot of people tell me, well, the strangler pattern is great, but what if I'm not in the same ecosystem? What if I'm on-premise? Or what if I'm on a different cloud provider, or in a different hosting solution, or I have a computer under my desk? And that's when the lift and shift approach comes very handy. You can basically grab that application that you have under your desk, put it in the cloud in a similar environment where you want this application to be. Maybe you don't get the full advantages of going to serverless, full on, but then it's easier to start doing the strangler pattern because you can start migrating bits, small bits and pieces, and start getting the 100% benefits. So in this talk, I want to focus on the lift and shift aspect, because this is a quite common problem for many people getting started with serverless, and mostly for full stack developers. So the agenda will take you through most of the things that a web application have: the database, the backend, the front end, authentication, storage, and we will look at different services and solutions that will help you to do this migration. I will show you an application built on Node.js and React and Mongo, but everything I'm going to show you, you can apply it to almost any framework or any kind of web application. So it's just, I want to show you a demo. So let's look a little bit at the application that I built for you. So you can see there that it's on-premise, it's in localhost. And this application is just a simple e-commerce. And in this e-commerce, you can do what you can do in any commerce. You can do filters. You can see all the products. All these filters are backend filters because I'm very bad with frontend. You can search. You can see the products. You can add things to your cart. You can remove things from your cart. Whatever you expect from an e-commerce. You have users. They logged in. They logged out. They register. I don't know. Typical things. So this is the application I built in order to showcase this problem, because it's a quite complete application with a lot of scenarios that our customers face day to day. So as I said, this application is a web application. It's a free tier application. It's built with Mongo as a database. Again, it doesn't matter, but in this case, we are using Mongo. Then we have Node and Express as our server, as our backend. And then we have React as a web view. So I will migrate each of these different components to the cloud, to serverless, and let's see what happens. So every migration has requirements. And even though I'm here doing a demo for you, I have to put some requirements. If not, I could do whatever I want. And that's not, well, it's more fun, but it's not realistic. So every time you're doing a migration, you have to adhere to some kind of requirements. That's a reason why you're doing the migration. So I put, in my case, some requirements, some constraints. So I have to find solutions that adhere to those constraints in some way or another. And I will show you during the migration process that there are many solutions to many problems, to the similar problems, but they don't adhere in one way or another to our requirements. So first requirement, I want this to scale to 0 and scale up automatically. I want to have little infrastructure as possible. I'm a developer. I don't want to have a lot of cloud infrastructure. And I don't want to worry about the availability of the application. I'm a developer. I'm doing this from the perspective of a developer. I don't want to think how many copies of my application I need to have everywhere. I want the cloud to handle that. And then it's a lift and shift. I want to make as little changes to my original application as possible. So with these requirements in mind, let's start migrating. The first step is to migrate the database. In my application on premise, I have the Mongo database in a container. So I want to put that in the cloud. There is many ways to do it, but because this is not a database talk, I will tell you I just use Mongo Atlas. Mongo Atlas is the serverless alternative for Mongo. You create a cluster in the cloud, and boom, you throw your data there, and it just works. It's magic. It's not in AWS, but it's perfect. It's just scale up, scale down. If you pick exactly the same region, it's just fast and nice and crispy. In the resources, I will show you how you can migrate a Mongo database to Dynamo if you're interested in that, and you can follow the same process for migrating any database to Dynamo if you want to go to 100% AWS serverless, but that will take a lot of information. So now we have the database. But let's migrate the backend, because that's where I'm very, very interested. So for the backend, we have many options. There is, I don't know how many different ways to deploy containers in AWS. I count last time 18. We have also instances. We have Lambda, and everything in between. So I put here 3 solutions that I will say they are more the most serverlessy that you can find: Fargate, AppRunner, and Lambda. So if we look at our requirements and we have those in mind, let's understand a little bit about Fargate, AppRunner, if you're not familiar with it. So let's start talking a little bit of the application that you have on-premise or in other provider or in other hosting service. You might have a virtual machine or some kind of machine with an operating system, a runtime, an application. You might have multiple copies of that application. You might have a load balancer. You might have some way to do auto-scaling. You might have built a CI/CD pipeline and things like that. If you want to keep exactly the same, well, just go to EC2, our elastic compute cloud. There you have to do all the heavy lifting, all the work about availability, build everything for yourself. And I consider myself a very lazy developer, and I don't want to do this work. I want that AWS does most for me. So in 2017, we announced Fargate. So Fargate are serverless containers. So here you can see that the AWS responsibility increased. Now there is a lot of bits of your operating system and the container runtime that you don't need to handle, but still you need to handle your application, you need to handle the load balancer, you need to handle the auto-scaling, you need to handle the CI/CD. So that's too much work for me. But luckily, in 2021, we announced AppRunner. So if you're a container lover, this is a lazy developer like me, you will love this service. Basically, here, you just worry about your application. You don't need to worry about any runtime problems, any load balancer, any auto-scaling, any pipeline to deploy. Everything is taken care of by AWS. So this is a service that I use a lot when I want to deploy applications, just lift and shift them to the cloud. Because this service allows me to, if I'm using one of the supported frameworks, that there is many, that allows me to basically put in GitHub a repo, not containerized repo, just a repo with my application, and then AppRunner will build it for me. So what AppRunner does, well, it's a service that abstracts everything for me, and then creates this kind of web application or API hosting. So for web applications and web apps, that is what we are building. This is a great solution. So the amount of runtimes that we have available, there are quite many. I recommend you to check the documentation, because this keeps on changing all the time, and we keep on increasing more supported runtimes. And this allows you to build any kind of application in where you have an API that you need an API back. So any kind of backend, and then any kind of service that you're using APIs. But it doesn't only work with those supported runtimes. You can have anything. If you want to build an application, I don't know, that provides API from COBOL, you can do it. Just put it in a container and figure it out yourself. You put it in ECR, in our container image repository, and you can still get that application and get an API for it. But I like more the GitHub way, because it's so fast. You create your GitHub repo, you create the connection, and boom, AppRunner creates the service, creates the load balancer, creates the provision the CPU, provision the memory, creates all the CI/CD. So meaning when you put a new commit in that app in GitHub, boom, it gets deployed automatically. And then at the end, it returns you an endpoint that is behind the load balancer. So whenever this service is scaled in the back, it's just handled by that API that you don't need to worry about that load balancer. And then your applications just connect to that API. So this is a great, great service. But it doesn't scale to zero. AppRunner has very good idle times. So it has a different way of pricing you when it's idle, when there is no request. But still, it doesn't scale to zero. So when we think about scaling up to zero, Lambda might be the way to go. Lambda is our serverless functions, and a lot of you might be thinking how you can put a web application into Lambda without refactoring. And yeah, we can do that. For that, we have the Lambda Web Adapter. That's an open source extension that you put in your Lambda functions that basically will wrap your application and transform those events that Lambda receive into HTTP requests that your application understands. So basically, you can have events coming from API gateway, from functions URLs, from application load balancer into your Lambda function. And because this Lambda function is wrapped around this extension, now everything gets translated from those events into HTTP, into your application that you just throw inside that Lambda function. So that's pretty neat. Now you can basically throw any kind of application into Lambda. Doesn't matter the framework, it doesn't matter the runtime. If it's something not supported by Lambda, just put it in a container file, and container image, and boom, throw it to Lambda. And my favorite part of this is that you can still do local testing, because you have a web application that you can npm start in your browser, in your computer, and you can test if everything is working, and then you just deploy it to the cloud. So it's very, very nice. So Lambda adheres to all our migration requirements. So good, we can pick Lambda. If we pick Lambda, we need to pick an API, because Lambda doesn't come with an API by default. Well, it comes with one, but you need to enable. That is the Lambda functions URLs. But you can choose API gateway or application load balancer. All of these works with the Lambda Web Adapter. If you're using AppRunner, as I said, AppRunner already has its secure endpoint that you can start using right away. So as we can pick any of these options, application load balancer, API gateway, and Lambda functions URLs, I just want to show you a little bit about Lambda functions URLs. That is something that is relatively new and is part of the Lambda service. So it's a feature that we announced some time ago, and it will give you an URL to your Lambda functions. So basically, you can define these nice URLs, and that can invoke a function. It doesn't have as many features as API Gateway, but for some kind of applications, some use case, this is very, very useful. So let's look at the features that it has. First, it has authentication, and you can put it either open, please don't do that, or then you can put it behind some IAM role. So if you want some other service to invoke that function, you just give permissions. It supports CORS. We all love CORS. We need CORS. And then it comes with some new metrics, so you can understand the performance of your Lambda functions URL, how many requests, the latency, the errors, typical things. Then it has some input payload, so path, HTTP method, query string parameters, body if you're in a post. And if you're working with a Lambda web adapter, this will translate into your HTTP event with no problem. It also does the same for response. If your function doesn't have a response, it doesn't return anything in a meaningful way. It will just infer the response. I would say it's at 200, and whatever is in the response will be returned. But you can also build the response by saying the status code, the type, and the body, and things like that. And again, if you're working with Lambda Web Adapter, whatever your HTTP response is will get translated into the Lambda function response, function URL response. And the nice thing of the Lambda functions URLs are the limits, because API Gateway has its own limits, and sometimes it's a little bit challenging for some particular use cases to work with. But when we work with Lambda functions URLs, we keep the same limits as Lambda has. So 6 megabyte response and request payload, the same limitations that you have, account limitations that you have for Lambda, in default account 1,000 transactions per second. You can increase it. And then a 15-minute timeout, meaning that you can do pretty interesting things with these URLs, have clients open, have response streaming, and build all kinds of things. And the nicest thing, you don't have to pay for it. It comes in your Lambda cost. So now we can migrate our backend if we want to go the AppRunner way or we want to go the Lambda way. We are covered. That's how we do it. So now let's go to the next part, that is the web app, the React part. And for that, if we want to go through the serverless way, we have kind of two options: Amazon S3 and CloudFront, or AWS Amplify. And Amplify uses Amazon S3 and CloudWatch. So I will go with Amplify route, because Amplify not only does the hosting for me, but also brings a lot of capabilities for my front-end applications. I will not use them all, because there is so many for building, shipping, and scaling my application, but I will use many of these features in this migration. The first feature that I will use is the hosting, because that's why we invoke Amplify. That will allow us to host this web app in the cloud. The second feature I want to use is the CI/CD, the continuous deployment. So I can put this web application in GitHub again, and whenever I make a commit, it will just deploy it in the cloud. I can have multiple branches in my GitHub repo, and those can represent different environments in my Amplify application. So I can have dev, test, and production. I can have environmental variables that are linking my backend to my frontend, and they are linked to these different environments. So I can build very, very interesting things when I'm hosting. And then later on, you will see that I'm using some libraries from Amplify. So this is how the Amplify console looks from the perspective of the CI/CD. So you can see here, I have only one environment that is main, or it could be called prod. And then all the steps of deploying, whenever I make a new commit, it just goes through all the steps of deploying. And you can add information and test and configurations in each of these steps. If you want to create an Amplify application using infrastructure as code, it's a recommended way. You can do it with CDK, CloudFormation, whatever you fancy, Terraform. Basically, you define the GitHub repo and that configuration. Then you can define the environmental variables, and then you can define the branches that you are going to use from that repo and which environment they represent. And then in your front-end application, you need to add one file. That's a change that you need to do in your front-end that will connect this Amplify application that you created in the cloud with your front-end application. And what it will do, it will translate those environmental variables that you're passing through the infrastructure to your application. So maybe they don't have the same name, or maybe they are, you need to do some kind of matchy-matchy thingy, and here is where you will do it. Also here you will do all the build process, so if you need to do testing, or you need to do some packaging, or you need to do whatever you need to do in your build deployment, you will do it here. And this is how the environmental variable looks from the Amplify console. So you can build as many environmental variables. I like to do my front-end agnostic from the backend, so I can deploy it in whatever environment, whatever account I want. And to create that agnosticity, I use environmental variables a lot. And you can see in the side that it says branch. So depending on the branch that you are you might have different configurations. So you can have the server URL for dev, server URL for test, and server URL for prod, and have a different connection from the front end to the back end, depending on which stage you are. So it works pretty neat. And all of this is provisioned with infrastructure. So now we have the backend, and we are 20 minutes. Bye-bye. Have a good day. Or no. We have some issues. So let's look at the first issue. So this is my application. You can see it's in Amplify already. This has been lifted and shifted to Lambda. I have not touched the code. I just grab my function and throw the code inside it. So I'm logging in. This is a test user that is working. I have migrated into Mongo, so it should be there. So let's see what happens when I log in. Did I log in? No, I didn't log in. So what happened here? This is a typical state program when working with Lambda. When you work with the Lambda web adapter, what will happen is that every request that your front end does will do it against a new execution of the Lambda function. So we do the login, and because we have not changed that code, the Lambda function will do whatever the login of the original server does. In this case, we'll save the user in the server memory. When we do the get products, it invokes a new function in a different environment where there is no user in the memory. And then when we get the menu, that is that top bar that will tell me if I'm logged in or not, there is no user in the memory because it's a new execution of Lambda function. The state is not shared between these functions, so we need to fix that somehow. There's many ways to fix it. The typical developer will have to build things. Let's create our own authentication microservice. More pragmatical people say, let's use a Redis-like solution so we can abstract that session into some top layer, and we don't need to worry about it. The lazy developer will say, let's use something that someone else created so I don't need to worry about it. I'm lazy. Because the first two solutions don't really adhere to our migration requirements. If we start building our own microservice or we use a Redis-like solution, we'll need to start worrying about the availability. We will need to do a lot of changes in our code. We'll need to build a lot of infrastructure. And our environment will most probably downscale to 0. But if we go through the managed authentication service, everything is green except one. And that's making changes to the code. But those changes that we are going to make to the code are my favorite type of changes, are the ones that we are deleting code. So I love those. I'm just not creating code, I'm just removing code. So for that, you can pick any managed authentication service that you want. There is many in the market. I will go through the AWS way because I'm already in the AWS ecosystem, so I can build this with my same infrastructure as code tools. I can integrate it with Amplify, so it comes with a lot of advantages. But if you use something like Auth0 or others that are in the market, it will have many of the same solutions. So for this, I use Cognito. Cognito helps you a lot when it comes to build these authentication and authorization systems. And there is two concepts that you need to understand from Cognito. The first one, that is the typical thing that these services does. That is a managed user directory. It creates all the users somewhere in some database. It gives you some way to do UI login. It gives you a way to manage passwords, get validation codes, validate email, validate text messages. It gives you access codes, refresh codes, tokens, and things like that. But the unique thing from Dynamo that is my favorite is the identity pools. Identity pools, what they do is they give you temporary credentials to your AWS account, to those users that are registered to your application. And you might be wondering, why do I want to give temporary access to my AWS resources to all these users? And because in AWS, anybody that needs to do something in your account needs to have permissions to do something in your account. So for example, if you want your users to upload an image or a document to S3, they need to have permissions to do so. And Dynamo will solve that for you very, very easily. So now we can modify a little bit of our backend to, instead of using some custom content and validation for validating the access tokens, we just call Dynamo to validate that. And we remove the logic from registering, login, and logout from our backend. And then in our Amplify application, we can basically just call Cognito whenever we want to log in, register, or log out, or do get tokens. So for that, we are using the Amplify libraries. Again, very simple, log in with username and password, and Amplify will take care of everything. So now we have solved one problem. The next problem is related to storage. So I will upload an image. Our clients can upload their own products. And you can see that it's not working. So this is because our original application has this upload folder inside its code. I know it's not the best practice for a web application, but it's quite normal. And when we lift and shift this code, we just grab this code and we throw it into a Lambda function. So that's why you can see all the images. All the images are inside this Lambda function. The problem is when you want to upload a new image, Lambda doesn't allow you to change the code of the function that is running. If you want to change the code or any object that is inside that Lambda function package, you need to redeploy the function. And that's not very practical, upload an object and redeploy the function every time. So we need to remove that upload folders from inside of our Lambda function. We need to put it somewhere else. And also because Lambda has a limit of 10 gigabytes of storage, so we don't want to abuse that. So for that, we have two options. We were already using a file system, so we can keep on doing that. We just use a cloud file system. Or then we can use, again, Amazon S3 and CloudFront. If we go through the file system way, we will add more complexity into our application, even though in our mind it's the simplest way to go, because we were already using a file system. The EFS service doesn't have, it's not serverless, so you need to worry about the availability. You will need to configure quite a lot of infrastructure. And then if we go through the S3 and CloudFront solution, we have again this situation where we just need to change a little bit the code in our application. But again, it's that good change that we just remove functionality from our backend and we rely on third parties. So if you don't know what CloudFront is, it's our content delivery network. It provides these access points all around the world to deliver content faster to our customers. And when we are working with web applications, we really want our applications to be fast because customers don't have patience and they get bored very fast. So we want to have that speed. So how this works, imagine that you have your customers in Australia and you have deployed everything in Ireland. So the first time that customers want this little cat picture, it will request it, and it will go through the CloudFront closest to them, and CloudFront will say, hey, I don't have this image. And then it will go and pick it up from where you deployed in Ireland and bring it back. Because of the laws of physics, this takes a long time. Even if you have optimized this image as much as you want, still the light and the data has traveled distances, and you can calculate how long it takes. So you want to reduce that time for most of your users. So after that user has get that image, the next users connecting from the same location, in this case Australia, whenever they want that image, now they will get it from their CloudFront distribution edge. So this speeds things up a lot, and we want that from our web application. So that's why CloudFront is very, very important, for example, for storing images. So now we can change in our Amplify the ways that we are uploading our images. We upload them to S3. And the way that we are displaying the images, we are just displaying it through a CloudFront distribution. And then in our backend, we remove all the logic related to uploading. How it looks when we upload an image, again, we use the Amplify library to upload the image. We say which image and where we want to upload it, and boom, it's in S3. And then, because this is React, I created an image component, a CloudFront image component, that I use instead of a normal image component that will build this image URL with the distribution name that I passed from my environmental variables. So whenever I just want to display an image, I just use this component, and all my images are coming from the distribution that I have, and they are not coming from directly the S3 bucket. They are always coming from the distribution, and CloudFront will take care of fetching them if needed. So this is the application. Now it's migrated, and you can see this is how it looks in real time. I'm not speeding things up. I'm just showing it how it looks. You can see that it's an amplifier. The backend is Lambda. The only thing I'm speeding up is my typing. If not, you will be here for 2 hours. But you can see that I'm registering a new user. This is using Cognito in the backend. And the confirmation of the user, this code, is also coming from Cognito. So that's good. I can log in. And now you will see that the login works. I can upload an image that's uploading to S3 and then get delivered with the CloudFront distribution. I can create a product. We'll see it right away in our main page. I can do filtering. And again, I can buy that product. I can do everything that I needed to do from this e-commerce with very, very little changes to our code. So now you might be saying, well, Marcia, whenever we think about Lambda, we think about cold starts, we think about low performance. Lambda is not for this. You should not use Lambda. Lambda bad, bad, bad for this type of applications. And I will say, well, let's do an analysis. That's the best way to understand things. For the front end, to test the end-to-end, what the user will feel, I'm using something called Page Speed Insights. That is a service that is out there that allows me to understand how well the application performs from the front-end perspective, from the client perspective. And for the back-end, I always like, and I always recommend when you build cloud applications with multiple infrastructure components to run load test. For that, I'm using Artillery. That is a service, it's a framework, open source, that you can download. And you can run load tests in your computer, or in Lambda, or in Fargate clusters. And it's very, very powerful. And in these ways, with this backend test, I can understand the bottlenecks. I can understand the latency of my requests. And I can understand where I can improve all that. So this is a Page Speed Insights. Let's see what happens. This is not optimized for mobile, so it sucks. But for desktop, I optimize it as much as I can. And for optimization, what I did is basically optimize the images to have the right sizes and the right format for the CloudFront to return them very fast. And the response is amazing. It just works very nice. Then this is how you define an artillery test. It's basically a YAML file where you define the target, you put your scenarios, how you want the different requests to be sent, and then boom, you say, okay, run this artillery locally, run it on Lambda, run it on Fargate, and it will run it for you. So this is something I totally recommend you to use for your cloud projects, serverless or whatever. And then we can look at the migration requirements. We have achieved this one. We have, if we are following the Lambda path, our application scales to 0. If we are using AppRunner, it will cost a little bit on the idle time, but not much. We configure as little infrastructure as possible, even though I show you 20 million different services. These services are not high on configuration. They are not high on building infrastructure pieces. They are just creating the component and say, hey, this is the bucket name, or this is the distribution name, or this is a function, and here you can find the code. They're very, very simple pieces of infrastructure to manage. Then we don't have to worry about the availability. All the services I show you today, they are regional services, meaning that the cloud will handle the availability for you, will handle how if there is a problem in an availability zone, how we will do the trade-off, how we will move it around the different availability zones, so it's not something you need to worry. And we make very little changes to our original application. We remove code most of the time, and then we replace some code instead of calling the backend to call some other service, but it was quite minimal. So that's what's next. Now we are in the cloud. So now we can apply the Strangle pattern. We can look at what are the most used APIs, and we can refactor them and take advantage of serverless. We can then add event-driven components. That's very, very simple when you're in the serverless world. You can have automations now when the customer uploads the image, so you can optimize the image on their behalf, so you can keep that page speed up and high. Or then you can add event-driven, so whenever a new product is being ordered, you can add, okay, the order is created, now I can take action and have my backend systems to respond to it. Or then you can extend that application, add new features, our personalization, recommendations, AI, and all these trendy things that are going on, and use serverless components from the start when you're building these things. So here you have all the materials. There are 30 videos around that will help you. There is a migration to Lambda. There is the migration to App Runner. And there is a migration from Mongo to Dynamo that you can use for most of any database to Dynamo. So this material is quite in-depth. That will take you through this path of migration many times. But if you're interested in migrating your web app, maybe something you need to check out. And yeah, if you have any questions during the migration process, just reach out in social media. And we have a few minutes for questions, so I'm happy to answer some, or then I will be around for a while. Thank you. Well, if no questions, or you have one? Yes? That's the main problem. The Lambda part is not a problem, because if you expect that load, you might have already increased your limit. For example, if you are raising more than 1,000, if you're in a default AWS account, you have 1,000 parallel Lambdas that you can have running. It's quite many. But your MongoDB connections, that's something where your load testing becomes very handy, because that's the first bottleneck that you are going to face whenever you want to scale this up to a lot of performance. That's why I end up migrating to Dynamo, because then you have to pay for the cluster, or you need to start paying for very advanced clusters, and it becomes a little bit trickier. And when Dynamo, you just pay for request, and you just can scale up as much as you need. So that's a really good question, because it will be the first bottleneck you are going to face. If you don't know what is the limit of requests that you can take, that Mongo connections will really think. Well, you can. The thing is that with the connection pools, it becomes something harder to maintain, because you need to manage that yourself. So then, if you are going to experience more than, when you're working with Mongo Atlas, you are going to define how many connections you're going to have. So if you're in the free one, it's like 40, but if you go up, you have many, many. So might not be a problem. But if it becomes a problem, my recommendation is just to get out from there and pick other service that doesn't limit you in the connections. And that's why Dynamo is a good option, because you don't need to open connections to use it. But again, Mongo Atlas can scale very much. So it depends on what is the business that you have running here. And if you are all in Mongo, why to change? You might already master that thing. But it will be one of the first problems that you encounter, at least with the free tier of Mongo Atlas, yes. Yes, other question? No? OK, but I'm on social, so just reach out if you need anything.